Okay, you just tell me when to start, then I'll. Okay.
Shall I? Um, shall I start? Okay.
Audio mute moderator.
Good morning, all the participants. Hello. Hello. Okay. Good morning, all the participants. Okay, okay. Good morning, all the participants, and our hearty welcome to Shri Prashant Kamath. I am very happy to introduce Prashant Kamath to you, all of you. He is presently heading quality initiatives for HR at Flipkart in Bangalore, Karnataka since 2019. And he has obtained his PG DBA in finance from Symbiosis Center for Distance Learning. He is a graduate in commerce and MTech in finance, both graduated and master in finance. He is net qualified in business administrative and management, and he has 15 years of rich experience with the BPO and KPO industries. To his credits, he has demonstrated abilities in cementing healthy relationship with the corporate clients for gathering business and accomplishing business and corporate goals. He has proficiency in handling systems and procedures for charge management in many operations like mapping processes, studying requirements, designing, implementing, and transitioning. He is an expert in customizing processes, solutions, product in line with the guidelines specified by the partners. He is also good at ensuring business functionality adherence and enhancement of competitive advantages. To his credits, he has track record of successfully planning and executing complex solutions. He is specialist in lean management, Six Sigma, continuous improvement, process transitions, operations management, resource budgeting, process training, balance scorecard, MIS, KPI implementations, process governance, and audits. He is an apt resource person for this FDP. And with this brief introduction of Shri Prashant Kumar Kamath, I am very happy to introduce to you all Shri Prashant Kamath. Thank you, sir.
Thank you very much for that detailed introduction. Good morning to all the participants wherever you are. I hope you and your family members, your friends and relatives all are safe, considering the situation through which all of us are going through. With it, I will quickly introduce today's topic, which is data patterns and measurement techniques. This is a very important component of the Lean Six Sigma journey that one typically goes through, because Six Sigma is all about looking into data and measuring the data in order to find out what is the data trying to tell us, right? And it is only through data that the Six Sigma journey is considered as complete. Otherwise, if you remove the data from any business problem, it's only a statement. It's only an emotion or expression. There is nothing in a business problem if you take out the data from it. So therefore, it is important for us to know what do we mean by data, what are the patterns in a data, how do we measure the data. Data is something which is available all around us, right? We know if somebody asks you what is the population of your district or your taluk or your city, that information is available at a click of your buttons on your phone. Or if somebody asks, because most of you are faculties in various colleges, if somebody asks you how many students have scored, say, more than 70% in a particular semester, that is something which will be available in the college records. Similarly, if somebody asks you what is the distance between, say, Bagalkot to Hubli, if you drive via car, you'll be able to tell that it takes so much time or it is so many kilometers, right? So data is something which is available all around us. It is just that we need to know where is the source, what is the data telling us, how do we analyze the data and draw inferences from it. That is the most important thing. And in today's session, that is what we will be trying to cover. I will not get into the introduction, as Krishnamurti sir has already given a very elaborated introduction of mine. So I will quickly get into the topic Six Sigma. And this is something that all of us have been listening, learning, and understanding for the last few days through various faculties. Distinguished members from the industry have come in and given their piece of knowledge. And today I am just going to maybe add few points and also try to teach you something which will help you to come up the learning curve in a nice manner. So the question that might have been asked over the last few days, and you guys have understood by listening to various faculty members, is what is Six Sigma? Six Sigma, some people call it as tools, some people call it as a technique, some people call it as a knowledge base which has a variety of problem solving methodologies, etc. etc. But at the end of the day, as I mentioned at the beginning, it is a fact based problem solving methodology. What do we mean by fact? Facts are nothing but data. If you have data related to a problem, we can solve that problem looking into the data. Why are we going to look into the data and solve the problem? Because we want continuous improvement. Improvement is a continuous journey. 15, 20 years ago, none of us thought that one day we all will be using smartphones, right? Even this session which is going on online, we couldn't imagine that a knowledge sharing session can happen where the instructor is about 400, 500 kilometers away from your place and delivering an online class. How did that happen? What are those circumstances which led to this revolution? Is nothing but continuous improvement. The technology that we had, we went on improving it on a regular basis, on a continuous basis, and that is why probably we all are in a position today where at a click of few buttons, people from two different parts of a state or two different countries, or even for that matter two different continents, can get connected just like this and start talking to each other, start seeing each other, exchanging knowledge and information. That is what continuous improvement is all about. So Six Sigma is a method which uses critical thinking skills to help all of us drive or take sound business decisions and deliver positive business impact. Whatever is a business problem, we understand what the problem is through data, then come up with innovative solutions or creative solutions, and thereby implement them in order to create positive business impact. So this is a simple way of understanding what Six Sigma is. And for beginners, I always recommend to go with the basics, get them strong, and then move into the advanced topics of Six Sigma. Because the more we learn in Six Sigma, the more we end up exploring. It is never a ending journey. Just like it is called as continuous improvement, the journey is also a continuous one. The next question that comes is Six Sigma problem solving method. When do we use this? What are those factors or circumstances under which the Six Sigma methodology of solving problem is used? First of all, there should be a problem, okay, a known problem, but we don't know what the solution is. Many a times we end up in a situation where we know the problem, we know the solution, so what we do is we just go and fix it. Say, for example, if a tap is leaking in your home, we know that something is wrong with the nozzle of the tap. What do? You just open the tap, remove the nozzle, bring a new one and fix it, the leakage stops. So there the problem was known, the solution was known, and we just implemented it, right? So in such circumstances, Six Sigma cannot be used. We should have a problem for which there is an unknown solution. We don't know what will lead to solving that problem. Secondly, when we solve the problem, it should address the business objectives. The core business objective should get addressed through solving that problem. Let us say a business says the sales of Maruti cars are very low in Bagalkot district. It's a business problem of a Maruti car dealer. But we don't know why the sales are low. Is it only Maruti whose sales are low, or are the competitors also facing the sales low sales? Is nothing but you collect data. You collect data of Maruti, you collect data of Santro, Hyundai, you collect data of other car manufacturers, and then see if everybody is facing the problem, or is it only Maruti, right? So it should address a business objective by solving a problem. Thirdly, the problem should be of a manageable size. That is something which we can, identify the problem and collect the data, analyze it, come up with solutions, and ensure that those solutions are sustained. All these things should happen within 3 to 6 months. We cannot take a problem which will take years to get solved and try to solve it using Six Sigma. We don't recommend that. Uh, it is like this. To boil a cup of water, we may take 2 to 3 minutes. But imagine if we are trying to boil an ocean in the Indian Ocean or Pacific Ocean. It may take millions of years, right? And by then, so many things would have changed. So therefore, we should always identify a problem which we can address within a gap of 3 to 6 months, or maybe 7 months. 1 month here and there is always allowed, and it should be a problem of manageable size. And therefore, we recommend that when we identify a business problem that we want to solve, it should be a manageable one, something that we can control. And the fourth point is the most important one. Data can drive decisions. I've been saying this over the last 10 minutes. It's all about data. When I gave that example of Maruti sales being down, that's a statement like Maruti sales are down. There is no data in that statement, right? But if I say compared to last year, Maruti sales are down by 25%, now I'm talking about data. Because say last year we sold 100 Maruti cars, and if I'm saying that this year the sales are down by 25%, it means so far I have sold only 75 Maruti cars, whereas at the same time last year I had sold 100 Maruti cars. So do you see the difference from me saying Maruti car sales are down versus compared to last year Maruti car sales are down by 25%? This is the difference which comes due to the data that we collect. So therefore, data is the key factor that can drive decisions in a typical Six Sigma way of solving problem. The next point is about different opinions could exist about the problem. If you ask the showroom manager of the Maruti sales showroom, he may say people are not interested in the brand of Maruti. They now want to buy Kia Motors or MG Hector, the new ones that have come in the market, or something else, right? But if you ask the sales agent who actually interacts with the customer the most, they will say, sir, of late the quality of the car has been poor. It cannot sustain the bad road conditions of India, and therefore people are not buying. So do you see how the opinion differs? The manager felt that people have other reasons, whereas the sales agent feels it is the quality of the car. If you go into the manufacturing plant of Maruti, the engineers who work on it may have a different opinion about the problem. But doesn't matter how different these opinions are. While using Six Sigma methodology, we will investigate into each of those opinions and find out how true it is, so that we can take that right decision in order to fulfill our business objective. And in this example, it is increasing the sales of Maruti car, right? The next and the last point We need to be open for new perspectives. By just saying solve a problem with using Six Sigma methodology, if the senior management of a company is not ready to accept some of the creative solutions that the project is going to tell, then there is no point in doing Six Sigma way of problem solving. Because most of the times what happens in a Six Sigma kind of a project is we end up discovering a unique way of doing things, a unique way of presenting solutions. If I have to give you an example, until 2 3 years ago, we had a practice of presenting the union budget, the financial budget, towards the end of February or March. And from there, it used to take 2 months further to get the budget live, funds getting allocated and distributed to various sectors. Because of that, by the time the funds reach the concerned departments, 2 months of the next financial year is already over. It's already May or June first week. So then effectively you are left with 10 months to spend, not 12 months, right? So what is the solution that they thought? And remember, they did not use Six Sigma. I'm just giving you an example here. They, instead of presenting the budget towards the end of February, they decided, why not present it at the beginning of February, so that you get more time to do the subsequent activities and thereby allocate the funds right at the beginning of the financial year, and therefore somebody gets to spend that money for 12 months, right? So when this proposal came, we don't know who proposed it, but when this proposal came, there was an open-minded attitude to look into the proposal, go through the pros and cons of it, and then take a decision saying, yes, we will go with this or we shall not go with this. Either ways, right? That openness for new perspectives should exist. It's only then a Six Sigma journey will be successful. Okay, so these are some of the factors that I would say should exist when we want to solve a problem using Six Sigma methodology. Let me go to the next slide. What is this method? And I'm sure you guys would have already seen this as to how typically a journey of Six Sigma problem solving method is. It is known as DMAIC, DMAIC, where D stands for defining the problem. First, we need to know what is the problem that we want to solve and what is the impact of that problem as of today. Let us say in your college, all the faculties get together, collect data around the average score scored by different students over the last 5 years. Collecting that data is fine, but what is it that you are trying to solve for? Are you looking to improve the average score scored by the students by 10 marks or 20 marks, or say 10% or 20%? That becomes your problem. And why is that you want to solve it? Because you feel that due to the less marks scored by the students, the college is losing its reputation or its name in the market, right? So that becomes your business problem and the impact. So it is very important for us to understand and define what is the problem and what is its present impact on an organization. It could be a commercial organization, it could be an educational institute, it could be a charitable institute, it could be a hospital. You name the sector, I can give you examples of how to implement Six Sigma in those areas. Once you have defined the problem, now comes the next and the most important phase, a phase which we are going to talk a lot today: measure. Measure. It's all about measuring. Now, in my define phase, if I say many students are scoring less marks, this is a statement. I gave you an example earlier. It's a pure qualitative statement. We are saying many students. How many students? We don't know. And then we are saying are scoring low marks. What do you mean by low marks? How low is low marks? Is 50 out of 100 a low mark? Or is 45 out of 100 low marks? Or is it 60 out of 100 low marks? That needs to be defined, right? And if you say, for example, anyone who has scored less than 60 out of 100 is considered as low, then we need to know how many students. Say if you have 100 students in your college and you say anybody who scores less than 60, we consider it as low. Okay, out of 100, how many have scored 20, 15, 10? Getting to that information is very, very important. And that is what is known as baseline measure. How do we establish our baseline measure? The baseline would tell you that in the academic year 2019-2020, 24 students out of 100 scored less than 60 out of 100. See how the problem changes from we saying many students have scored less marks. Now we have a data to tell us that 20% of the students have scored less than 60 or have scored less than 60 marks out of 100, right? Once you know what data you have to collect and you have collected it to establish baseline measure, then you go to the next phase called as analyze, where you try to find out what are the root causes of the problem. In this example, why did 20 students score less than 60 out of 100? What are those factors which are leading to this problem? Why are they not able to score more than 60? Is it an issue with learning? If yes, which are those subject, which is that chapter, which are those chapters in a particular subject which these 20 students are finding difficult? And what specific aspect of that chapter they are finding it difficult? You try to analyze, you compare the learning curve of all these students and get to know the root causes, the main causes which are leading to this problem where students are scoring less than 60, right? Once you get to know the root causes, then the next phase is about improving, where you try to find out what changes will eliminate the sources of the problem. What is it that we need to do in order to overcome this problem? In this example that I gave about the students, say you find out that there are 3 chapters in a particular subject which all these 20 students found difficult, then the management might tell you, can we conduct a special class? Can we conduct some additional and teach the same thing in a different manner, in an easy manner, so that they understand what that chapter is trying to tell? And that is where the improvement or the innovation factor comes in, where we get together as a faculty, students into confidence, telling them that we will teach you these things once again. We will ensure that you overcome the learning curve and start scoring more marks like the remaining 80 students, right? So that is how you bring that improvement amongst the students. Once that is done, lastly, you have to control it. Taking them through the special class, additional class and all is fine, but then they need to do their bit of job also. If you have given them extra assignments, you have to make sure that they are doing it on time. You have to check if they are doing it on time, they are doing it in the right manner, and thereby understanding the complexity of that chapter. That is what is called as control. Okay, in the previous example of Maruti cars, if we had ended up concluding that it is the quality of the car which is bothering people and that is why they are not buying Maruti cars, then that feedback will obviously go to the senior management of Maruti, where they will not only listen to this one dealer. Such feedback they will collect from different dealers across India. And if all the dealers or most of the dealers are saying, sir, the quality is very poor, people are afraid to buy such cars, then it is an input that management will consider seriously, improve the quality of the car. Now, improvement is not just one-time activity. Once we change the way of making the cars, we need to sustain that method. And that is where the control phase, the last phase of Six Sigma comes. Anything that has been changed, how do we sustain it over a long period of time is what control is all about. Okay, so this is the journey of a typical DMAC kind of a setup. And today, as I said, I will be talking exhaustively about the measure phase, where it's all about data patterns and measurement techniques. Okay, let's understand what is this measure. Just take few seconds to read through this before I talk about it. So it's all about quantified evaluation. And I've been saying this. It's all about quantified evaluation, no qualitative expression. Qualitative expression is only a statement. It could be an emotion, it could be somebody's frustration, it could be somebody's expectation. But a statement can never be considered from a measurement standpoint. So, therefore, in measure, we are going to look into the quantitative aspect of a particular data. For example, length of time, say speed or age. We may also refer to size of a product in terms of its length, height, or weight. Sometimes measures could be in terms of revenue or rupees, cost of product, sales revenue, profit of a business. And many a times we could also refer to characteristics in the form of counts, like types of customer, types of payment, types of vehicles, or gender. Sometimes we may count defects, and at a later stage, I will tell you what a defect is. For now, you can say instead of calling it as defect, you may call it as errors. Both would mean the same. Errors, late deliveries, complaints received by the customer care, all these are nothing but the data that is associated with the business that we are running or the problem that we are trying to solve for. This is what is measured. You quantify the characteristics or level of performance based on observable data. You collect the data and you then start measuring it. However, certain data can always be expressed in a particular manner only. For example, if I have to tell distance, in India, we will always measure it in kilometers. If you go to some of the Western countries like United States and other places, they will measure it in miles. Have you ever seen data getting measured in kilograms or liters? No, right? The distance. So a particular measure will always have a particular way of expressing it. And in this example, as I said, the distance between place A to place B is always in kilometers. Similarly, the weight of a particular product is always measured in kilograms, say in India. In other countries, some of them do it in pounds. But within a country, you will not have variance between, say, Karnataka measuring it in kilograms and Andhra Pradesh doing it in pounds. You will not see that variance, right? So these are some of the measures where we have defined rules as to how we would like to measure it. Okay. The next question is, why do we measure? What is the need to measure? These are some of the points, and few of them I've already covered, so I won't get into the details of it. We want to establish the current performance level. As I said earlier, 20 students are scoring less than 60 out of 100 in a particular subject. So that is your baseline. We get to know where the problem is. Determine priorities for action and whether or not to take action. Once you know the data, you will get to know where do we need to focus in order to solve the problem. It also talks about the magnitude of the problem, how big or how small the problem is. Then it provides us insights into potential causes of problem, why this problem is occurring, why is it has been there for a long time. That also gets addressed when we measure the data. And then last but not least, we want to do this, we want to measure the data to prevent problem from occurring again, and also predict future performance. In future, how are we going to perform as a business unit or as an educational institute? To know all these things, we need to collect the data, we need to measure it. It is as simple as that. I'm not going to complicate it at all. There are many aspects related to measure, but today I'm going to make sure that your basic knowledge of data and measurement is becoming strong than what becomes stronger than what it was. If you ask me how tall I am, I can say I am 5 feet 6 inch. That is nothing but numeric expression of my height. So data is something which is available all around us. We just need to pay that extra attention to know what the data is and what is the right way to become an expert in looking into the data aspect and collecting it for inference purpose. So I have a very short and a crisp definition about data. Unlike in academics, we have definitions which runs into lines and sometimes even a paragraph. I would prefer to keep it very short and sweet, where the word data means known facts or numbers. Anything which is in the form of number and known to us is data, right? If today science is so advanced that we can very accurately measure what is the distance between Earth and Mars, or Earth and Moon for that matter. Maybe few hundred years ago we were not in a position to do that, but today it's a known fact that it takes so many days or months to reach Moon, or so many years to reach Mars, right? That is nothing but a known fact, which in general is known as data. These are some of the examples of data. Take a minute to go through it and understand what each of those bullet points are trying to tell. The first one is talking about number of cars sold in Bagalkot district by Maruti Suzuki. So there it's about the count of cars. The second one talks about quantity of grapes grown by farmers in the year 2019. Is it saying of a particular location? No, that information is not there. It just says quantity of grapes grown by farmers in the year 2019. The third one talks about students who have scored 75% or more. Number of students who have scored 75% or more in all semesters, not just 1, 2, or 3 semester, in all semesters, but in mechanical engineering department. So when you have to collect this data, how will you go about it? You will first find out those students who have scored 75% or more in all semesters, but in mechanical engineering department only. We are not worried about other departments, and we are not going to look into those students who have scored less than 75, right? That's what that statement tells. The next one is about time taken to travel in a car from Bagalkot to Hubli. Read the statement carefully. Time taken to travel in a car from Bagalkot to Hubli. The place of origin and destination are same. But don't you think the time taken to travel in a car will be different than time taken to travel in a government bus versus time taken to travel in a two-wheeler? So the statement is telling you need to collect data related to travel from Bagalkot to Hubli, but using car. But it's not saying which car. That's another factor, because different cars have different level of performance, and that will influence the time taken to travel. But the statement, what it is saying is time taken to travel in a car from Bagalkot to Hubli. So you will not look into time taken by a government bus to go from Bagalkot to Hubli. Okay. The last but not least, amount of rainfall received in the year 2020. I know the monsoon is still on and the rains are still coming. But as an example, if you want to know how much rainfall did we receive in the year 2020, that is usually measured in centimeters for a time cycle of 24 hours. In 24 hours, a particular place received how many centimeters of rain. That is what the statement is talking about. And these are very simple examples of what data is. Okay. So far I covered the theoretical aspects of what is measure, what do we mean by the word data, and so on. Now let's get into the data types and understand what is it trying to tell us. Take a minute to go through this. Data at a high level is divided into quantitative data and qualitative data. That's the first high level classification that happens. Before talking about quantitative, Let's quickly cover qualitative because that is not part of today's curriculum, and I just want to introduce it to you and move on from here. So qualitative data, as I said earlier, is all about statements, expressions of emotions, frustration, opinion, ideas, etc. If I say the food is very tasty, how much it cannot be expressed in numerical terms. All you are saying is the food is tasty, or the place is very far. Now, when we say a place is very far, typically we should be expressing it either in the form of time taken to go to that place or distance to go to that place. But if I say place is very far, it's a qualitative statement. Or let's say students have scored very good marks. What do you mean by very good marks? How good is very good marks? What is that number? Without that number, the statement students have scored good marks is only qualitative statement. It is of no use. It can just give you some information saying many students have scored good marks, but for beyond that, it is of no use, right? So that is why today's session is all about quantitative data. Data, as I said, which is in numeric terms, in the form of numbers or percentages sometimes, is what we call as quantitative data. Within quantitative, we have two types: continuous data and discrete data. This classification is very important: continuous and discrete. And today's session is all about these two. Okay. I have given some examples about what do you mean by continuous data. It is height, weight, distance, temperature, etc., and many other measures. These are few examples that I've given. Where a particular attribute is measured in a particular manner only. There cannot be another way of doing it. As I said earlier, is always in kilometers, and in some other countries it's in miles. So wherever there is an ability to measure a particular attribute of data, it is called as continuous. Whereas discrete, it's all about counting. Number of students in a classroom. You are nothing but doing, but you are counting. The count could be 50 students, 35 students, 40 students. Then you can further break the data saying out of 40 students, 18 are female, remaining 22 are males. You can also collect further data saying of the 40 students, 20 are from Karnataka and the remaining 20 have come from different parts of India, right? So in this way, you can count the data, slice it in different ways based on your requirement. Percentage of marks, well-known measure in the world of academics. What is the percentage of marks? And all of us know what it is. This is called discrete data, where there is no measurement. You are not measuring using a scale or a unit of measure like height, like kilograms, Celsius, kilometers, etc. This is known as discrete data. Now let's get into each of this in a detailed manner. First, I will talk about the hello, madam. Hello. Okay. No problem, madam. I hope the issue is solved now. So, madam, from which slide onwards did we face the disturbance? Like I was talking about medium. Okay, fine. So let's get back. I will quickly begin with the definition once again so that we are able to stay with the topic. As I said, median is the middle number in a sorted ascending or descending data. And we use this when we have too many outliers in a given data set. That is where we start using median instead of mean. Mean is nothing but average. And then I showed this data table where we looked at some of the extremely high values and some of the very low values also being part of the data set, right? These red numbers, which are much different from the remaining part of the data, is usually known as outliers. Now, when we have such outliers, the rule is we shouldn't use mean, we should use median. Now, the question is, what will happen if I use mean? Mathematically we can calculate the average. It is not going to stop us. Madam, I quickly want to check if you guys are able to see me. Okay, sorry, the camera was switched from. Sorry. Okay, so my question was, what will happen if we calculate mean for this data set? It is possible to calculate. Nothing will stop us from calculating the mean. Let us do it and see what is the outcome. Mean is 131 minutes. Okay, the average time for 12 days is 131 minutes. Is it the right way to look at the data is a question, right? Because in the previous example of mean, we saw the average was 103, the maximum was 108, and the minimum was 100. So 103 as a value was close to 108 as well as 100, right? But look at this now. The average is 131, and from 131, data point 209 minutes is very far away. Similarly, the data point 100 from 131 is again far away on the scale, right? So basically the data is scattered. When I look at the mean, the center value, the data is spread outliers. We don't take mean. Largest ascending order. Okay, and in this set of sorted data, ascending to ascending order, smallest to largest, Hello, madam. Yes, I'll just share my screen. Just give me a minute. Madam, please confirm if you are able to see me. Okay. And is the slide visible as well? Okay, fine. So while looking into the data set, we calculated mean where we got 131 minutes as the average time or the mean time. Then because we have too many outliers in the data set, we decided to calculate median instead of mean. And accordingly, we arrange the data in an ascending manner where the smallest value is on the top and the largest value is at the bottom. From there, we found out which is the middle value of the data set. And in this case, it is 108. This is what is known as median. And then we were trying to infer what is this telling us? What is it telling us? 108 is a middle value, but what do we make out of it? The interpretation is simple. 50% of the time we took 108 or less minutes to travel, and for the remaining 50% it is more than 108. When I say more than, it can be any number. It can be 209, 163, 155. All these values are more than 108. Now, what do we do with this? Once we get to know the median, if you know that 108 is a mid value, then you need to find out why are the remaining values more than 108, or why did we take more time to travel more than 108 minutes, like 144 is more than 108. We would be interested to know that particular day, why did it take 144 minutes, what happened that we took more time, right? Or on 10th of June, we took 209 minutes, which is almost double the time that the median is telling us, right? What happened on that day that instead of taking 108 or less minutes, we took 209 minutes, right? So this is how you then do the investigation. Remember in the DMAC, I said first we define, then we measure, and then we analyze. In this example, we analyze the median and select a range. You will get the median on its own. But before you do it in Excel, it is important to learn to do it manually, which is in this fashion, where the data is arranged either from smallest to the largest, or you can also arrange it largest to the smallest. It will not make any difference. 108 will still continue to remain the middle value. So this is the fundamental difference between mean and median. And as I said, median is used when we have too many outliers in a given data set, and outliers are extremely high or extremely low values in a particular data distribution. Okay, so this is what median is all about. Now let me go to the last measure of center, which is known as mode. Mode is one measure of center which I would say we hardly use in day-to-day activities. It is only from an academic interest I'm covering this. Otherwise, mode is that measure of center which is almost never used. But it is good to know what mode is, because when we learn some of the advanced measures of statistics, at times mode plays an important role, but it's not a significant player. Okay, so mode is that number which appears most frequently in a data set. The number which repeats again and again and again is known as mode. As simple as that. Here is one data set. Just have a look at it, and for yourself find out which is that one number which is repeating again and again and again in the data set. That number becomes your mode. And in this example, you are seeing that 102 is that number which has repeated 3 times. Rest all numbers have repeated only once, right? So therefore the mode of this data is nothing but 102. Now if you recall all the 3 measures that we found so far, in the first when we learned mean or average, we got 103, right? Then we calculated median and got 108. Then we calculated mode. Now we got 102. All these 3 values are in closer proximity to each other. Don't you think so? The values are closer to each other. In the previous example of median, using that data set, when we calculated average or mean, we got 131 minutes, right? I'll quickly take you there. See, we got 131. This 131 is very, very far away from the mean that we calculated, which was 103. And it is also far away from the median 108. And here it is also far away from the mode. But the mode, the median in the previous slide, and the mean that we calculated first 103 are in closer proximity to each other. Basically, telling that for a particular data set, when certain conditions exist, we should either use mean or median. And because of that, when we do that, the mode will be always closer in proximity to those 2 values. That is what is the inference. And as I said, mode is not something that we use on a daily basis. This is purely from academic interest that I have covered this. Okay. So far on the measures of center, we have covered mean, which is also known as average. We have covered median, which is also known as the mid value. And we have covered mode, the value which appears most frequently in a given data set. Okay. So that was about measure of center, mean, median, mode. Now let us talk about measure of spread. The spread of the data, that is what it means. There are many such measures in spread, but for today's session, I'm going to cover the ones which are very basic and important ones. We are going to talk about range of data and standard deviation of the data. Okay. So what is range? Very simple definition. It is the difference between the highest and lowest values in a given data set. In a given data set, you will have a highest value and you will have a lowest value. The difference between them is called as range. As simple and straightforward. Have a look at this sheet or this data set. Read through it and understand what is it that it is telling. It is talking about few students and the marks scored by them. Okay. Don't ask me which subject, I've just randomly put it over here. Now I need to calculate range for this. What is the formula? Take the highest value from the data set, identify the smallest value, subtract 2 from step 1. That is, subtract smallest value from the largest value. What you get is range. And in this case, the largest value was scored by Peter, 144. Lowest value was scored by Ajay, which is 100. And the range is 144 minus 100, which is 44. Easy to calculate, but how to infer? Inferencing from the data is what we do in Six Sigma. The range is 44. What is it telling us? Is 44 the right range? Should it be more or should it be less? Why is it 44? Right? While inferring range, the thumb rule is lesser the range, better the replication of overall performance. Now, we should be knowing why did Ajay score 100 and why did Peter score 144? Why can't Ajay score 144? Or why can't Vijay score 100 and who has scored 102? Why can't he score 144? right? So when the range is too large, we need to find out what happened with the lower values. What is going on here? Why are these students scoring about 100 to 102? Why did Sumant and Peter score 139 or 144? Right? Uh, so when we look at the range value and we feel it is too broad, that is when we start investigating into the lesser values. Right? Now, for your calculation purpose, if I remove Sumant and Peter from this data range, okay, and retain the rest of them, the highest value will be of Ravi 108 and of Ajay it will be 100. Now if you calculate the range, you will get 8, not 44. So what 8 tells us is that we are very close to the scores that Ajay, Vijay, Suresh, Mahesh, Raghav and Ravi have scored are close to each other. The proximity is close and the range is 8. So 8 is a tolerable range. Like you cannot have all students score same marks, right? Some will score 102, some will get 103, some will get 100, one will get 108. So the inference that we make if I remove Sumant and Peter is smaller the range indicates consistency in marks scored by different students. The overall process is stable, right? But if I add Sumant and not Peter of a sudden, indicating that some students have scored very less, some have scored more, and so on, right? So the thumb rule is lesser the range of the data, more consistent is the process. Okay, as simple as that. It's a very simple measure, but very effective one to understand, the spread of the data and find out where the problems are. Like in this case, as a teacher, you would be interested to know why did Ajay, Vijay, Suresh, and Mahesh score between 100 to 102. What is it that is working well for Sumant and Peter that they are scoring 139 and 144, and thereby come up with the solution in order to make sure that the students who are scoring less marks can score more. Okay, so that is what range is all about. The next one and the last one for measure of spread under continuous data is standard deviation. This is slightly complicated, but it is not something that we cannot learn over a period of time through continuous practice. One will easily get it, but you have to read through this definition, take a minute to go through it and understand what standard deviation is actually telling us. It is a measure of amount of variation of a set of values. You have a data set. Obviously, one data point versus second versus third, there will be some variation. Variation is nothing but difference. Like marks, I said somebody will get 102, someone will get 104, another one will get 103, then the next student will get 105. So from one student's mark to the another student's mark, the difference is known as variation. Okay, that is what standard deviation is all about. A low standard deviation indicates that the value tend to be close to the mean of the set, that is average of the set, while high standard deviation indicates that the value are spread out over a wide range. It's all scattered. Like we saw in the previous example, one student got 144, another student got 139, and many students have got only 100, 102, 103, 104, right? So what do we mean by low standard deviation then? How low is a low standard deviation, or how high is a high standard deviation? We'll get to see that now. Okay. So standard deviation is a measure of the amount of variation for a given set of values. Again, there are few students, okay, and they have scored some marks in a particular subject. If I have to ask you to calculate range as an example, okay, find out the highest marks in the set Rama, 72. Find out the lowest marks scored by a student in the set Samira, 60. 72 minus 60 is 12. So the range is about 12. Okay, and between this 72 and 60, remaining students' marks are identified. Like Harish got 68, Raghav got 66, Sailaja got 65, Vijay got 69. All this are between the highest value 72 and the lowest value 60. Between these two are the marks plot. Correct? Now I want you, that was range. What we calculated was range. Now I want to know the standard deviation. And you will see how standard deviation is different from range now. Okay. To do that, when you actually practice this at your desk on your computer or laptop, you can do it in two ways. One, there is a formula in Excel itself for standard deviation. You type that formula, you select the marks code column, you press enter, the deviation will come. That is by system generated. But it's important for you to know how it is calculated manually. When you calculate it manually, that is when the concept becomes strong. That is when you will be in a position not only to measure it, but also teach it to many people, saying this is what standard deviation is. Okay, so let us have a look at it and find out how standard deviation is calculated manually. Okay, take the data first into an Excel sheet where you first enter all the student names, then enter their marks. Okay, I have all the steps listed out here. Read the step and understand what is it that I am trying to say. Once the marks are entered, make a total of this. All the marks, you will get 656. The total of all the marks scored by all the students. Next, find out how many students are there. From Prakash till Samira, we have 10 students. Okay. Total of all the marks scored by these 10 students are 656 and we have 10 students. Divide 656 by 10, which is nothing but average or mean. You get 65.6. Average score scored by 10 students is nothing but 65.6. From the individual marks scored by each of the students, subtract 65.6. I repeat, from the marks scored by individual student, subtract 65.6. Not 65 from 63. You first take 63 minus 65.6, you get minus 2.6. Then 68 minus 65.6, you get 2.4. Don't worry if the values are coming in negative. Okay. In that way, again, 61 minus 65.6, you get negative 4.6. In this fashion, you calculate the marks minus average in next column. Okay. Now, whatever value you get here, whether negative or positive, you calculate the square of it. That is minus 2.6 multiplied by minus 2.6, you will get 6.76. Similarly, 2.4 into 2.4, 5.76. So calculate the square of all the values that you got here. You will get these individual values, right? 6.76, 5.76, and so on till 31.36. Once you get the square, make a total of it. 150.4. Make a total. Then divide that total by number of students. How many students do we have? 10. So bring that 10 here to get 15.04. Okay. Calculate the square root of 15.04. You get a standard deviation of 3.88. Okay. I know this is slide. I want you to calculate. Worry. Just calculate marks minus average. Marks minus average will get the value. Based on the values that you have got here, calculate the square of it. You calculate the square and make a total of the squares. That is from 6.76, all these numbers you add to get 150.4. Then you divide it by the number of students, which is 10, to get 15.04. Okay. Then you calculate the square root of this number 15.04 to get 3.88. What is this 3.88? This is the standard deviation. Now, if you recall the definition, what was the definition? Amount of variation of a set of values. A low standard deviation indicates that the value tend to be closer to the mean of the set, while higher standard deviation indicates that the values are spread out over a wider range, right? Now, with this standard deviation, 3.88, what is it trying to say is, if the average is 65, sometimes the score of a student is 3.88 less than the average, and sometimes it is about 3.88 above the average. Okay, so let's validate that. Samira has scored 60, right? Average is 65. So directly, if you compare it, you may not see the